Go for deploy.
Understood. Drifting to the right, level. Contact right. Eagle has landed.
Hey guys, Tori here from Overlook Horizon. We made it! We're live! Finally! You've been waiting all day long for this SN8 hop to take place. I can't guarantee that it will take place, but we hope it will, and we're getting closer to an actual launch attempt. People have been bouncing off the walls all day. When's it gonna launch? Why is it delayed? What's happening? Why do you keep changing the stream time? I don't know. I know just as much as you know. Maybe a little bit more, but we're getting there. All right, so we've been waiting all day for SpaceX to get a little closer to a potential hop, and we're finally getting closer. Now we are getting very close to the end of the launch window, which is a little I don't know, but we got good signs so far. So let's talk about what we've had here for today. Oh, before we do that, I do want to say, because sometimes people get in here later and they forget all about what's happening. This is right now December 8th, 2020. It's 4:26 p.m. Eastern Standard Time. We're expecting a launch maybe. Don't at me in the comments if this is wrong. Maybe at 48 minutes ish. Ish. It's like 2 Minute Tuesday. It's ish. It's not actually 2 minutes. We're ish. Somewhere in this range. So, what's happening today? We get the breathing under control. Deep breaths. All right. Let me tell you what's been happening here today. So, we had a lot of rumors flying all over the place today on what may or may not have happened. Rumor has it that there were some hydraulic issues earlier that they were working on. It seems like everything's good to go. So they ran some tests a little bit earlier in the day. Then they sent the maintenance crew back to the pad. Now those tests earlier, they still had the chains and the straps on the flaps, the little flappy things on my little short. I'm missing the center section of my Starship here. There's supposed to be another section there, but this is my 3D printed center section, which actually just finished printing like 5 minutes ago. So there's my little, almost the Starship. It'll be better. But the flaps here, the ailerons or whatever we're calling these things, the little wiggly flaps here, it looked like they still had the straps or the chains on them that kind of lock them in this back position here like this. Could have been for like, wind management or something like that, so you don't have a big surface to kind of just blow the thing over. But they were still on there originally today. And then they kind of pushed, they left the pad, they did some testing, they sent the crew back to the pad. We knew they weren't going to launch at that point because you can't launch with the chains still on the flaps. So they sent the crew back. We saw a lot of activity with the little cherry pickers, the little, the lifts that they have there. They took the chains and the straps off. It looked like maybe they were doing a little bit of work on the flight termination system, maybe activating it. And then they've now cleared the pad. The recondenser is now active, and we're starting to see tank farm activity. So that's good news. That's a good sign for a potential hop here today. So usually that starts about an hour before they might try a launch, is when you start to see that. So they have a methane recondenser, and we used to see a big flare stack. Now they have a methane recondenser. That's basically that they can recondense their methane instead of burning it off with the flare stack. They can recondense it. You start to see a lot of activity from the methane recondenser as they start to fire things up here. So we are we're seeing much more activity than we had seen previously. So this is a look from NASAspaceflight.com, who gave me permission to use their footage here, so thanks very much to NASA Spaceflight, along with their entire team. If you haven't been watching NASA Spaceflight today, you're missing out, because they've been streaming for like almost 12 hours now, and it's been fantastic just listening in, having all the camera views that they have for them. So if you don't want to listen to me and you just want to see the raw footage, go head over to NASA Spaceflight. There's a link in the description and a pinned comment there. You can head over to NASA Spaceflight and check them out if you're sick of listening to me. So we're getting everybody's Oh, my camera was no good there, huh? Okay, I forgot. I know exactly what was going on. Everybody's freaking out about when I switched to this camera view. I forgot to edit. I forgot to turn off. I was getting double audio there. Thank you for that. Appreciate that. We should be we should be good now. Sorry about that. So what I was saying when we were in this view, this is a view. I'll say it again now that I fixed the audio problem. This is a feed from NASAspaceflight.com. They gave me permission to use this. They've been streaming all day today for like 12 hours now. It's been fantastic to listen in. So I said it once already, but if you don't want to listen to me, just in case you couldn't hear me through the audio problem there, if you don't want to listen to me, you can head over to NASAspaceflight.com for their raw coverage here, because obviously I'm not there. I don't have video footage. If you just want to see that without me, you definitely go head over to them. Okay, so I just wanted to redo that since the audio was all askew there. So we'll take a look at first, we'll give you kind of an overview because we've got some time, but one of the biggest indicators that I've been watching today to find out if they're actually going to launch, and this is really, I want to stress a couple of things about this launch. Number one, this is a test flight, all right? There is only 20 to 30% chance that this thing even lands today. Like, if it lands today, I will be shocked. Like, I am completely expecting it not to land today. But if it does land, that would be fantastic. But this is a test flight. It doesn't have to land to be successful. So it's not a failure if it crashes and burns, because they're going to learn stuff throughout the way. There's a whole bunch of stuff they're going to test today that we've never tested before. It's got to launch. It's got to do this whole belly flop maneuver. So the thing's going to launch. It's going to do this belly flop maneuver and come down like this. Pretend there's a middle section here because I didn't put it in. But it's going to belly flop like this. They've never done that before. They got to be able to control the vehicle with these aileron flaps or whatever we call these things. They're going to control the vehicle with those, which is going to be kind of crazy to see. And then the big kicker at the end, which this is the part where I'm like, I've seen all the simulations, the 3D renderers. They're awesome. Looks fantastic. But it's when it comes down, it's going to kind of come down like this. It may even pitch forward a little bit to kind of stream towards the launch site here. Maybe. We don't really know for sure. I'll show you an animation or some views in just a minute, but it may pitch forward like this, and then right at the last minute it's going to ignite the engines traveling horizontally this way, burn the engines back the other way to null that horizontal velocity, and then touch down like that. That's the part that has me going like, is that gonna happen? Is it? I mean, I know it's simulated, but I want to see that in real life. I'm like, that'll be kind of crazy. So I don't know if we'll see that. We'll find out. So let's take a look at, so again, one more time, just for the people that are not familiar with all of this, it's a test. It doesn't have to land to be successful. If it crashes and burns, it could still be a success. All right, so let me show you some of the things we got in store for you today. First of all, the thing I'll show you is we are going to use flightclub.io again today with our simulated telemetry. I don't know what SpaceX is going to have, but we've got simulated telemetry here from flightclub.io that'll show us the fuel in the rocket. Now, all of this is estimated. Nobody knows for sure, but this is all estimates on what we think might happen. Estimated amount of fuel in the rocket. Notice it doesn't need a ton of fuel. Also estimating throttle is only going to hit about 60%. Now this could all change. They could add more fuel to it and they could go 100% on the throttle. We don't really know. It's just an estimate. But anyways, we've got some estimated telemetry here. Altitude, we've got altitude now, velocity, acceleration, throttle, fuel, the active engines, which is what these 3 dots are here. So we'll have a bunch of this simulated telemetry here today during the launch, assuming it goes okay. Right? And it's going to look, yeah, I'll even show, it's going to look something like this. Here's, it just simulates it, right? So I can kind of start and stop it whenever I feel like. So we'll reset that, get it back to normal. All right, in addition to that, let's take a look at a couple other things. I guess while we're on the Flight Club bit, let's look at the animation that Flight Club has come up with on their expectations for the actual launch. So this is in Boca Chica, Texas. We should go back. Let's look at a map here before we get to the Flight Club thing. I know this is a 3D map, but I have a 2D map here. This is Boca Chica, Texas, way down by the border of Mexico here at the very southern tip of Texas. Right down here in this area. I should also switch back to this view here. Right down here, Boca Chica. So we're launching from there. That's where the Starship facility is. Right. Where did I go? I lost my bearings here. There it is. Right down here. So here's the village of Boca Chica. It's over here, not too far away. Everybody has had to evacuate there. Much bigger exclusion zone for this flight because it's a little more dangerous. So this is the actual facility. This is an old satellite picture from Google Maps, so we can't see it, but it's not traveling very far. It's going to launch from here, travel to here, only about 500 feet, like 160 meters from launch to landing. So it's not a huge variation there. That's where it's going to head to. Now the 3D map here. This is kind of a prediction, again, an educated guess of about what's going to happen. So we have the launch over here, the landing on the pad. We've got pretty much going to launch almost straight up with a little bit of a, maybe a little bit of a tilt out to sea, just for safety reasons. You can see here. It's going to be under powered flight, not all the way up to apogee. It's going to cut off, it should cut off earlier and then coast to apogee. Apogee was going to be 15 kilometers. Now it's about 12.5 kilometers. And that was likely a negotiation there with the FAA on whether or not they, what altitude they can go to. Because remember, the altitude that they're going to, the FAA is going to authorize that along with exclusion zones based on their comfort level on how dangerous or safe it is for the surrounding public. Because we have surrounding towns here, like right over here. This is where a lot of the media is out in this region, which is not too far away. I mean, yes, there's a lot of empty areas here, but the question is, like, worst case scenario, what happens if this thing goes out of control? All right, there are flight termination charges on it, so they can detonate the rocket if it's just gone nuts, but there's always going to be a little bit of a delay there, so you have to have enough of a buffer zone to be able to detonate those charges and have the corresponding debris land safely without impacting people. And the higher up you go, it's kind of like a cone of a danger cone. We'll call it the danger cone. Basically, it gets up to that peak altitude. If something happens there and they have to terminate it, or God forbid it terminates itself, there's going to be a danger cone of debris that comes showering down. So that's kind of how they determine that exclusion zone. And the FAA and SpaceX likely had some sort of negotiation there to say, like, okay, you can only go to 12.5 kilometers because that's going to give us, that sets us at ease comfort-wise. We know we have enough of a buffer there that if you guys just completely go, then we're going to be okay. So 12.5 kilometers is the apogee. So we should be under powered flight until about here. Apogee, then we do that belly flop maneuver, that whoosh, like this, belly flop, and then you're going to see at the end of the belly flop, if we zoom way in here, so the belly flop, if nothing happens, is not going to be straight onto the landing pad here. This is also an educated guess here, but belly flop to, just off the pad here, and then they will hopefully land it again with that crazy flip maneuver, which is just going to be insane. This crazy flip maneuver where they're coming down belly flop style, maybe even nose down a touch. Don't know that for sure, but could be nose down a touch to kind of point to and steer. Like, it's almost like flying like a plane at that point, like, because when you're doing that belly flop and you got the aileron wing flap thingers, it's point nose down coming towards the pad. Maybe not this drastic an angle, but it's easier to show on camera there. But so maybe you're coming in nose down, then it has to fire the engines, flip around backwards, fire the engines this way to null its velocity, horizontal velocity, and then touchdown. Hopefully in one piece. We'll see. Stardom. I'm assuming that's my friend Rod. This is the flap thingers. It's the official terminology. Not sure if you got the press release. That's what they are officially called, is the flap thingers. But anyway, so there's our 3D animation from flightclub.io of about kind of what we're expecting here, right? All right, a couple other things to look at, and then we'll go back to maybe looking at the rocket. There it is, right there, just so you get a quick sneak peek, and I'm gonna switch away real quick. One of the big things that I was waiting for today to determine whether or not we were gonna have a launch is this guy. This is NASA's WB-57, which is a high-altitude observation plane from NASA. Was leaving from up here in Houston, coming right down here to Boca Chica, presumably to observe the launch. It's got cameras on board, tracking cameras, things like that. It's a NASA plane. So that left about, we knew the travel time for the WB-57 was about 1 hour, and that left about half an hour ago. So we could see a launch at about half an hour from now. That's what I got on the clock. 33 minutes. It's an estimate. I'm guessing. It's a complete guess, right? It's an educated guess, but for the most part, a complete guess. But I was waiting for this WB-57 to take off, because that's pretty much when we knew, like, all right, they're going to give it a try. Like, they're sending observation planes down there, and that didn't happen until about 30 minutes ago. So that was one of the big things I was waiting for to determine if this was going to happen. So it's on its way, heading towards Boca Chica. It's not there yet. So it's about halfway there. It left half an hour ago. I said it was going to take an hour to get there. So I can math. So that's kind of what we're waiting on here right now. And let's see, what else did I have to show you here? We'll take a look. So for those that don't know what we're launching today, this is the Starship, right? So it's a prototype. It's not the final version, but it's a prototype vehicle from SpaceX. It's going to be their next generation rocket to take people to the moon and to Mars. This is stage 2 of the rocket. They haven't even started on stage 1. This is only stage 2 of the rocket. So this is like 50 meters tall, and the super heavy booster, which is stage 1, that'll be under this, is like, I forget what the actual, I think it's like 100 meters tall or something like that. So the thing is going to be enormous. It's already enormous, and this is just stage 2. So we've got, like I said, the flapper thingers, the side flaps, the wings, the ailerons. I don't know what we're calling those. We've got those side flappers. Two at the front, 2 at the back, or 2 at the top, 2 at the bottom, front, back. I don't know what we're calling it, but we've got those there. It's methane fueled and liquid, and it's also got liquid oxygen to bring its own oxidizer. You've got some raceways here that you can see for cable runs. That's what's kind of running down the side. This isn't like dripping down the side. This is basically like your cable raceways here. Falcon 9 has that as well. They look a little bit prettier, but again, this is a prototype. Like, they're just trying to figure out, like, does this work? Nobody has ever tried this maneuver before. We have no idea if this is going to work. They have no idea if this is going to work. I mean, I think they probably have a decent idea. All the simulations and engineering and a lot of thought has gone into it. But really, at the end of the day, like, they're going to be sitting there going like, I hope the flapperdoodle thingers do what they're supposed to do. I like that. Who said that? Cronin. Flapperdoodles. I like this name, the Flapperdoodles. So that's what we're trying. Here's a look. Here's the second stage that we can see there, along with the super heavy booster, which we haven't even seen. They're not even started on that yet. So that's the super heavy booster. We may see that someday, but they're going to need that to get to orbit. Haven't seen that yet. Here's what it's going to look like when it's all finished. That nice stainless steel shiny look. Hopefully you get a little polished up. You'll get some tiles on the back. You got your grid fins up here, and then some fins at the bottom of the actual super heavy booster. And should we play this? We've already played it. You guys have seen this before. I'm not going to play the video. So that's the idea. That's what we're launching today. Let's see. Did I have anything else that I need to show you... Yeah, I guess a couple things we could show you still. This is... Actually, let's take a peek real quick on NASA spaceflight. Do we have activity? I haven't even been paying attention to the chat, so... I have to... All right, so it looks like we're still progressing. Things are looking good. So, while we're waiting on maybe NASA to, or not NASA, SpaceX to go live, let's take a look at exclusion zone here, just to give you an idea as well. This is an aviation exclusion zone. This is sky vector, showing basically where the TFR is, which is this shape on the outside. That is the TFR, where basically plane traffic, aviation traffic must stay out of. That's been active pretty much all day today. So no aviation traffic allowed there without explicit permission, obviously, because like we said, you just showed you a minute ago, the NASA WB-57 plane, which is heading there right now. Obviously, that's going to be inside the TFR, but they have permission to do that. So... and then there was, let's see, what was that? I was going to show you. Oh, the flight club data. I did want to show some of this data from Flight Club, because there were a couple things that are a bit interesting. So obviously we can see a whole bunch of graphs here. If you want to go through this on your own, it's flightclub.io. You can check this out, simulate the whole thing on your own. And the one thing that I wanted to point out is the acceleration. A lot of people very concerned about the acceleration, especially on that belly flop maneuver when it does the little like Flight Club simulations only predict about 2.5 Gs, maybe 3 Gs of acceleration during that maneuver, So that's not a ton. That's doable for an astronaut, and they could also. We have no idea what the seating arrangement or the seating structure is going to be inside any sort of crew compartment. So for astronauts, they could potentially have some sort of seating system that could be on like a gimbal almost. That's, you know, they face up, and if the rocket does, let me get my model, does the little underneath them, like they could still face the same direction while the rocket does that underneath them. We don't know. Just theories and ideas, but even if they don't, it's still only about 2.5 Gs worth of acceleration. Now, whether you get motion sickness from being an astronaut and doing this whole woo maneuver, like that could be concerning, but we just don't know for sure. But there are some things that they could potentially do to mitigate any sort of risk there for astronauts during that flip around maneuver. Okay, so Laura Johnson on Facebook likes my sound effect. Is it the woo sound effect? You like that one? Let's see. Go through a couple of questions here. Let's get the rocket up. Where's our friends at NASA Spaceflight? We'll pull their stream up here so we can get an idea of what's happening, so you can see what's happening with the rocket. We're still progressing. We got some activity happening. You can see a little bit of the condensation clouds here. All completely normal. Just waiting to see if they progress towards an actual flight attempt. Now, we don't know. We really have no idea on a time. This is completely an estimate. 26 minutes. I would actually say we're probably... I think I'm gonna reset that timer, because we're not even we haven't even hit that section yet. So before I take your questions, I'm gonna even update this, because I would say my latest projection is probably might be more like this. I don't know. It's a guess. It's an educated guess. We'll see. Could be 30 minutes, 40 minutes. We don't know. We'll keep an eye on it. As things change, we'll update the potential launch time. So this is all going to be a guessing game here. And again, they still have to wait for the WB-57 to actually get there as well. They can't launch with this because this is going to do observations. That's the NASA plane, which is, it's getting pretty close. It's almost there. Probably get there. Let's see. What does it say? 523. Oh, that's the landing that they're expecting. 523. Is that right? No, that can't be right. That can't be right because that would be... Oh, that could be... Oh, now it's a 7:10. 7:10, that'd be local time, central time. I always forget they're central time, not Eastern time. All right, anyways, let's switch back. Let me grab a couple of comments here from the chat while we look at our friends at nasaspaceflight.com that gave us permission to use this stream here. So they've been running an awesome stream all day today. If you just want to see this, and you don't want to see my stuff, and you don't want to listen to me, check the links in the description, the chat down below. You can check out NASA Spaceflight, and you can just watch this. And you don't have to listen to me. If you want to hang out with me, that's cool. All right, let's see. Where are my comments? Around here somewhere. I have like a million windows open right now. Let's see. All right, there we go. Let's get to a couple comments and see what we can get to. Do you think SpaceX is going full Kerbal mode? I have no idea. This sounds crazy. Like I don't know what to expect today. I'm completely expecting it not to land. If it lands, like, that's gonna be crazy. I do want to also say SpaceX is going to have a live stream as well. So we're going to stick with NASA Spaceflight for a little while, then we'll probably switch over to to SpaceX's official stream once they go live. We're expecting the flight time to be about maybe 3 to 4 minutes total. Are they using any cheats? No, not that I know of, but we'll find out shortly, hopefully. The whole channel will go nuts if it lands. It's from Eric Boss, one of our channel members. Thanks for your support there, Eric. I couldn't agree more. I'm sure everybody's probably going to go nuts and just be like, oh my goodness. Like, I'm already like amped up and on the edge of my seat here. Let's see. What is the launch time? I don't know for sure. We're guessing. They're estimated guesses. Maybe I'll even go to this maybe while we're chatting so you can see the timeline. I don't want to put the timeline over NASA Spaceflight stuff. Water landing. I don't think we'll have a water landing because if you look at the and this is also, of course, this is just an educated guess, but if you look at the flightclub.io simulation, of course it is just a simulation, but it just barely goes over the water. You know, so at apogee, it'll hit here, and it should start coming back down. Now, initially, it would be heading towards the water, but as long as our flapper thingers, whatever we're calling these things, the Alanaron, what we gotta come up with a name, the flapperdoodles, the things on the thing, right? As long as the flapperdoodles do their thing, even if they just do their thing a little bit, it should come back over land. So I think we'll get a little bit of flapperdoodle action. The flapper thingers. My question really is going to come down to what happens at the very end, like that flip around maneuver, that big. That part is the part that I'm more worried about. I think it'll go up. I think it'll belly flop. I think the flapperdoodles will do their flapperdoodle thingers. They'll be doing what flapperdoodles do. But then the question is like, will it land or will it kaboom? And that I don't know the answer to. That's a good question. So, all right. I did want to acknowledge at least a couple of people here too. I saw Peter Balrica. Thanks for the super sticker there. Said cool. Thank you for your support. Really appreciate that. Riley sent over another super sticker. Thanks, Riley, for your support. Appreciate that. Then we had a bunch of channel members join. It looks like earlier today while we were hanging around. So really appreciate everybody supporting the channel there. Pony, Brad, Lim, Framrick sent over a super chat. That was like yesterday. Framrick sent that over. Thanks for that. Really appreciate it. So thanks, guys. All right. So let's get to. I should also acknowledge Ethan over on Facebook. Who's this? Ethan Davis. Donald, I'm going to butcher your last name, but they sent over some stars on Facebook. There's a new thing for Facebook, but that also supports the channel. So thanks, guys. Appreciate that. And Ian McLean, thanks for that. Really appreciate it. Okay, so let's did we go back to the rocket? Let's go back to the rocket, and we'll grab some questions here real quick. Footage courtesy of NASA space flights. There's a link in the description below if you'd like to see this without me. All right, if the structure handles that flip with the amount of data that they have of successful Falcon landings, it should land fine. Yeah, that is the one thing that's. Yeah, I guess there's a couple of things that are going to be interesting for this flight. They've never used the flapperdoodles, right? So those are a big unknown because they've never messed with those before. But as it gets towards the end of its flight there, and it's slowing down, like those are going to be less useful. They're probably not going to play a huge role in the actual landing. Once you actually get the flapperdoodles and touch down, like the flapper things are probably not going to do their thing. So they do have a lot of data from Falcon 9 to be able to do landings. So if anybody can do it, I mean, SpaceX has a huge knowledge base to be able to handle that. So I would think that they would be okay in that department. But the question really is, I mean, there's this brand new maneuver, this flip maneuver, and these brand new surfaces. Those weren't on the Falcon 9. So how are those all going to come together? There's also, there's always the possibility that they could have a hydraulic problem or some sort of lockup on the flaps, and they're supposed to be up, and one of them, gets stuck open or something like that, or doesn't respond. Like, that could be a real problem. So, let's see. Looks like NASA Spaceflight is reporting some tank farm venting happening, which is good news. That's usually about 30 minutes to launch. Vivid doesn't get the joke. Vivid View says you need to learn to pronounce the word right. It's ailerons. Vivid, it's a play on word. I'm calling them Elon-erons. I know how to say ailerons here that you're talking about. That's not what I'm calling them. I'm calling them Elon-erons. You get it? Is a joke like Elon Musk? Is it Elon-erons? Maybe I should slow things down for you, I guess. It's it. And Ike says, I like Ike, or whoever suggested it earlier, the flapperdoodles. All right, let's grab a couple other questions. +1 for flapperdoodles, says Eugene. Will Starship be able to launch in more weather conditions compared to Falcon 9 or Falcon Heavy? We don't really know, but one good thing is if they do launch Starship from Boca Chica, there's a lot. Boca Chica weather is a little more stable than Florida weather is, so that might not be an issue, but we just don't know. We got to wait till we get further on in the development process. I think everybody likes flapperdoodles. Tepid says it's a shame you have to explain your clever humor. I didn't come up with Elon-erons. I wish it was. I just really like the name. I think it might have come from like Everyday Astronaut or somebody, but I really liked the name Elon-erons. But I should slow it down for the people that think I'm saying ailerons. Let's see. Surfer 1201 over on our Twitch. Are you watching the chat? I am watching the chat, but there's a lot of people here. So I'm watching like 4 chat streams all at the same time. There's a lot to see. How many minutes will it take to land? So we're expecting the flight to be about 3 to 4 minutes. somewhere in that range from launch to landing. So also just an educated guess, 3 to 4 minutes maybe, launch to landing. That's, I mean, you're not going to be too much out of that window because it's not going very high. So you're only going to be like plus or minus a couple of seconds there. Just tuned in. When's it going up? We're guessing in like half an hour or so, but I may be updating that time soon because I think we may be a little bit closer than I'm actually showing on the countdown clock. So I got to keep an eye out on some of the activity there to see how close we're getting. But once we start seeing some venting from the actual rocket itself, then we're going to be maybe 20 minutes away. So we were expecting a flight somewhere around 4:20, 4:30. That's Central Time. So it's 4 o'clock now, Central Time. But we are, they were waiting on the WB-57 plane, which is pretty much in the area here now. So it's there. It made it. And now they would have to fuel the rocket and give it the go or no go. So we got to determine whether that's going to happen. Do you have a KSP demonstration for this one? We might demonstrate in KSP. We could do that. Let me grab a couple questions, then I'll demonstrate in KSP. I'll try. I'm not very good at it in KSP. It's way harder than you might think. What's the WB-57 plane for? That is a high altitude observation plane, so it's likely got some tracking cameras on it so that they can observe the full process, because they don't have as much camera facilities here at Boca Chica. So they're bringing in, and that actually right here, this looks like NASA spaceflight's got a view on the WB-57. So that's it right there. That's the plane that we were just talking about. That's the NASA WB-57. So that's the plane that's going to get that high altitude imagery. The tracking cameras there, flying over Boca Chica right now. So it has arrived. So it's going to kind of circle the area there, and we'll see if it happens. How high does it fly? I believe it's about 40,000 feet or so. Let's see, what are we at in altitude? 41,000 feet. Somebody have to do a metric conversion on that for me, but it's at 41,000 feet right now. Is what the WB-57 is currently flying at. Oh, actually, yeah, WB-57. Currently at, what was it at back here? Oh, it was in flight at 45,000 feet. It's kind of interesting, but it dropped down to 41,000 feet. So we'll keep an eye on that. All right, let's see. I'll go back to here, and I'll go back to here. We'll keep that kind of in the smaller window there. We're also waiting on SpaceX will go live at some point as well. We're expecting the Starship to go to an altitude of 12.5 kilometers, which I believe is about 40,000 feet. Is that right? Did we do that math right? 40,000 feet for 12.5 kilometers? Somewhere in that range? That's what we're expecting Starship to go to. So they should be pretty much at the same altitude there. This rocket will take 100 people to the moon and Mars? Never! Well, it would potentially, I mean, that's a potential. We still have to see. So just because it can fit 100 people doesn't necessarily mean that it will fit 100 people, or that's what they're going to put on. Because if you're going to send people to Mars, you're going to need space for just stuff like living. Like, you need space to stretch out and to exercise. I mean, it's not only going to be a vehicle for traveling, but it'll be a vehicle for traveling and, like, living. It's almost like a space station traveling to Mars during transit there. So you need other facilities, like, exercise areas, eating areas, someplace to, just to stretch out and do your thing. And, are they going to grow food or we don't know any of that kind of stuff. But those are some of the ideas on you know, if they're going to, plus you're also going to need a ton of cargo space too. If you're going to Mars, you're going to have to bring some stuff with you. So yeah, I don't expect 100 people to get on it and go to Mars, especially on flight number 1, but it's just kind of an idea on how much room it has. There's a good chance this craft will explode. Yeah, there is a good chance that it does not land. One of the questions will be, will we get a huge fireball if it doesn't land? And that's a big unknown because we don't really know how much fuel they're putting in the rocket. We have an estimate from Flight Club, which looks something like this. They don't need a ton of fuel for this maneuver. So based on what they need, let's see, where is it? It's right here. This fuel, what they need here is not a ton. But the question is, like, how much are they going to put in it? We don't really know. So if they only have a ton and they're really going to do the hover slam maneuver, which is basically when they hit, I mean, they are going to do the hover slam maneuver, but if they're usually with the Falcon 9, they have almost zero fuel left as soon as they land. And they may do that here. So if it lands, there might not really be a ton of fuel. So you might not have a huge fireball, but the tanks will still be pressurized and under pressure. So if it falls over or it doesn't land, like it could suffer a rapid unscheduled disassembly or a RUD, and it could look like it's blowing up, but really it's just being shredded apart by the pressure inside the rocket. It's not really like a fireball, but we don't know. We may never know, but hopefully we don't find out. But I wouldn't be surprised if it doesn't actually land. Attila, hey, thanks for becoming a member on the channel. Appreciate your support there. Couldn't they attach several Bigelow modules to accompany the main ship on their trip to Mars? It has been tested on the ISS and appears to work well. Yeah, I mean, there's all kinds of things that you could potentially do, but, then you got to remember, like, you're going to need, fuel to maneuver stuff, and how are you getting that up there? Is it going to be one of those, tiny inflatable modules? Like, how are they going to deploy it, or what? So we just don't know yet. We don't know what they're going to do. We're not at that point. Like, let's see if we can get this orbital first. How much is the total cost of this project? I don't think they haven't really told us. We don't know what the cost is. This is a private, it's a SpaceX. They're a private company. They don't have to tell us what the cost is. It's not like NASA where they have to disclose what their costs are. So we have no idea what the costs are for this particular project. We know that they're trying to get the launches super inexpensive, down to like ridiculous numbers of like a few $1 million per launch. But again, we're gonna have to wait until later in the process to see that. One of the big things that they have going for them is that this whole platform is 100% reusable. So there's nothing thrown away. There's no engines thrown away, which are super expensive. They don't have to build a brand new second stage like you do with Falcon 9. So there's a ton of benefits here because it's fully reusable. What are the odds? Elon is saying the odds are about 1 in 3 that it actually lands. And again, I said it at the beginning, but I do want to preface this one more time, that this is a test, number one. Number two, this is an internal company test. They are under no obligation to even share any of this with us. And number three, if it crashes and burns, it does not mean it's a failure, because they're developing, they're building this platform. So if it crashes and burns, it's not a failure. It's still a learning process. Like, they may get up and they get the flapper thingers, the ailerons, whatever we call them, flap ailerons, or what, I don't know. I'm trying to make up other names, but they may get up there and be like, oh man, those performed way differently than the simulations. Hopefully not. Hopefully they got those sorted out. But if that happens and the flapperdoodles don't do their flapperdoodle thingers, then they go back to the drawing board and they say, well, flapperdoodles didn't flapperdoodle like we thought they would flapperdoodle. So how many times can I say flapperdoodle? So then they may change the process and develop the vehicle, and that's good. That's a success, not a failure. They're furthering development, and they also have SN9 is coming right behind it, which is the next vehicle. So even if they lose this vehicle, even if they save the vehicle, might not fly again. They might fly SN9. All right, there's my rant. Flabberdoodles forever. It is going to land, but we don't know how many pieces. That is a good point, Henry. It will land. We don't know if it's going to be one piece or many pieces. What's the purpose of those flaps? So they're kind of going to play the role like the grid fins do. So they're going to be aerodynamic surfaces to passively control the vehicle on the way down so that they can steer it. Let's show you. Let's see. Let me pull up. Oh, I'm missing it. Hold on a minute. Look at this for a second. While we're waiting, let me pull this up here. So I can see this. Oh, looks like we just switched to propellant loading, so that could be good news. Because you can see our friends at NASA Spaceflight have updated their time frame to propellant loading. So that would mean we're getting close. That would be about 20 minutes away usually. Oh no, LOX venting is usually 20 minutes away. So no, we could be a little bit further away than that. Well, I'll wait. I'll wait on that. All right, let's go to. Where is it? I have somewhere. Here we go. Let's do this view. Right here. So here's our Kerbal Space program. Let's fast forward to daylight here. It's easier to see. There we go. All right, let me see if I can simulate this here for you. There's no guarantees. I'm not very good at this, but we're gonna try it. Okay? Here we go. So this is roughly what we're expecting here today. Via Kerbal Space program. Expecting it to come up, have like just a little bit of a pitch towards the ocean. Not a ton. I'm gonna kind of pitch it over a little bit more. It's gonna head up here. I make no promise. This might be, well, this could be what happens today. This could be a complete failure. But at this point, we're not expecting the flapperdoodles to be activated. The question is, are they going to be in flappy out mode or flappy in mode? We don't know. But expecting them to be in flappy out mode. Oh, well, this is going to be a 15-kilometer test because we went a little past our target here. So there we go. Engines are off. We're still climbing. This is going to be a little bit higher than we're supposed to do, but that's okay. We'll be all right. So it's going to head up. We're already at, we're going to head to like, this is going to be a 14.5-kilometer test instead of a 12-kilometer test. That's okay, though. So we're going to head up. Let's see. We'll tip it over like this because now we're falling. And now the tough part, okay, so now we'll activate our flapperdoodles here. There we go. Flapperdoodles engaged. Maybe even, and this is one of the things that we don't really know, like which ones are going to be engaged, which ones are not going to be engaged. So right now I got the front ones back, but the back ones are still flat. We're kind of going this way. I'm going to pitch it nose down a little bit, see if we can head back towards the launch site. There we go. see if we can do it. What are we at time? What? We're okay. We're doing all right. Let's see. Let's put those in up mode, those in back mode. Nope. Nope. That's not good. That's not what we want. Oh boy. Oh boy. All right. We got this. This might imagine this is how it goes in mission control, where they're like, oh. No, this is gonna be all autonomously controlled here. All right. Can we get back to the launch site? We're trying to steer it to the launch site, but this might be a water landing. We're coming in. Nope. Well, this is gonna be a water landing because I can't put. It's not pushing back. So let's see. Will it go? Will it go? Will it? Can we get it? We got some venting. We're seeing propellant loading. I see all that. Oh, yep. And well. Oh boy. Oh no. Oh no. Well, there's a that's not quite how it's gonna work. But there we go. Well, we're gonna land in the water because we didn't quite make it back to the launch site, but here it goes. And then we would touch down nice and softly. Nice and soft water landing. Look at that. Beautiful. Touchdown. Right in the water. So, there you go. Rough idea. Obviously, not the greatest here, but just trying to give you an idea on kind of what we're expecting and a little bit of what those the flapperdoodle things will do. So let's go. Let's see. Somebody just said, well, the SpaceX stream now says 7:30 p.m. That's Eastern time. That would be 6:30 Central. That can't be possible. That's outside the TFR window. Oh, wait. No, the picture says now targeting liftoff at about 4:30 p.m. Central Standard Time. So that's not far from now. That's like 12 minutes from now, because that's what my target time is 12:36. Ooh, we could be getting close here. We could be getting close. Hey, Crucial, thanks for the super chat. Says, you're awesome. Thanks, Crucial. Really appreciate that. I hope I'm saying Crucial. Hope I'm saying that right. Appreciate the support on the channel. Thank you very much. Doesn't less fuel mean that the belly flop will be easier? I would expect so. I would expect less fuel to mean that it's easier as well, which is why I'm not expecting them to completely fuel the rocket. So we've got just to give you an idea on timeline, SpaceX has got a statement here that says that they're targeting 4:30 p.m. Central Standard Time, which is in like 11 minutes. So we don't know. We could be up to 11 minutes. They haven't gone live yet. So we just don't know. Let's see, why is it so shiny? I mean, it is made of stainless steel. So this is stainless steel is really inexpensive to manufacture. It also handles the re-entry heating very well. We've had stainless steel rockets before. The old Atlas ICBMs were stainless steel. They used to be a very complicated process because the old Atlas ICBMs had to be pressurized pretty much at all times because they would collapse under their own weight. The stainless steel was so thin that they would collapse under their own weight. But they're not necessarily having that problem here now with the Starship. We've got some new materials that they can use here, but let's see. How many people will Starship eventually hold? It would be up to 100, but we don't know. We don't know if that's what we'll actually be at. Let's see. What else can I get for questions? Yeah, we don't know. We don't know time-wise. We're based on SpaceX's latest statement. They said about 9.5 minutes. Now, that's pretty close to activity we're seeing on the rocket here. So you can see we've got a lot of tank farm, all the condensation activity that's happening here. We've got propellant being fueled into the rocket. We don't see the big liquid oxygen vent yet. That usually happens at about 20 minutes prior to launch. So yeah, I don't, I'm kind of doubting that we're going to see the actual launch in 10 minutes, but that's what SpaceX's stream says is 10 minutes from now. But I would expect we're at least 15 minutes away because we don't see the big liquid oxygen vents happening yet. MECO is 9 minutes after launch. Oh, I'm expecting MECO more like 38 seconds after launch or something like that, like 30 seconds after launch. So it's going to be a very short flight, like 3 to 4 minutes total. Did I say? Oh, did I? He might be saying. Oh no, I have MECO right there. 28 seconds. I thought maybe I had a typo in my events list here. Let's see what else we've got here. Hey, Johann Rudolph, thanks for the super chat. Said cool, or super sticker, I guess that is. Thank you very much. Really appreciate that. A couple people are commenting about how SpaceX's live stream says they'll be live in 2 hours. If you're watching SpaceX live streams, don't ever pay attention to the actual live time that SpaceX is on there. Like, it is not reliable. Even on regular rocket launches, they usually set the time at launch time and then they go live early. So don't base your information on the time of their live stream, because they could start that at any time. Like, they could start it right now. Just be like, oh, surprise, we're here. You're going to want to base that on the activities that are happening. So like, we're watching what's happening with the Starship here. We're seeing tank farm activity. Like, that's going to be much more reliable. Any statements that they make, like they put out a statement that said they were targeting 4:30 p.m. Central Standard Time. Like, those are going to be more accurate. Like, I would not pay any attention to the actual live stream start time. And actually, it just updated just as I was ranting about that. It just updated to starting in 6.5 minutes. So listen, I'm not going to say I told you so, but I told you so. They just updated it. So, there's a typo in landing burn. It says attitude should be altitude. No, that is correct. It's attitude. It's the landing burn is going to orient itself in the proper attitude. Not altitude, proper attitude. That is correct. So yeah. Oh, here we go. Now we're getting some big. Now we're getting some big liquid oxygen venting here. This is good news. You can see the 3 liquid oxygen vents there. It's from each of the Raptor engines. There are 3 engines on this, not like we saw on SN5 and SN6, which only had 1 Raptor engine. There are now 3. It's also the first time they've flown 3 Raptor engines. So this is a big deal for SpaceX here as well, that they're flying 3 Raptor engines. They've done test firings on them, never flown 3 Raptor engines. So we've got the three venting here. We should have SpaceX go live soon. I mean, they're saying 5 minutes, but they haven't gone live yet. That doesn't entirely surprise me. I'm not expecting like a regular webcast where they have a host and everything else that they're going to chat it up with. Like, they're likely going to go live and they're just going to show it. It'll be, there'll be no commentators. That's what you got me for, right? Right? Yeah. So, let's see. What if they overshoot and go to 14.5 kilometers? Well, they're going to be much better than I was, but there are flight termination charges on here, so they will, if it goes off trajectory, they'll terminate the flight. Star Andrea 22, thanks for the super sticker, appreciate that. Mirik Cern, thanks for the super sticker, also really appreciate that. Let's see. Oh, Michael Zeller, thank you very much. Thanks for the super chat. Really appreciate your support on that. How will the ship keep its balance while landing on concrete? There are landing legs on the bottom. They've said that they're going to improve the landing legs. Potentially they want to have like auto leveling and things like that. But there are landing legs on the bottom. Remember, this ship is designed to land on the moon and to land on Mars, which you can't expect a perfectly smooth concrete surface on the moon or Mars. Like, you got to be able to handle all sorts of surfaces and things like that. So eventually, they're not there yet, but eventually they will have auto leveling legs and try to improve that a little bit. What's the temperature right now in Boca Chica? I don't know. They had, I think it's like 70 degrees Fahrenheit or something like that. NASA spaceflight, they had the temperature up a little while ago, but yeah, SpaceX is showing 3.5 minutes. I mean, that could be possible. I mean, we didn't see the liquid oxygen venting until just recently. Usually that's about like 20 minutes before launch, and it only started like 3 minutes ago, maybe. So I was thinking that they were more like 4:45 Eastern time or Central time. But I don't know. Do you think we can see it if it explodes? Yeah, we will see it. We will definitely see it. It's not going very far. SpaceX is going to have the live stream, and you have 1 million people down there, like NASA spaceflight, everyday astronaut, Lab Padre, S Padre. I don't remember who else is down there, but there's 1 million people down there that are filming this thing. Like, if it explodes, we're gonna know. We will know if it explodes. What's the altitude of the flip maneuver? It should be right at apogee, right at about 12.5 kilometers. There's about 40 to 41,000 feet in altitude, so it should be, I mean, it's basically gonna go up, reach apogee, and as it starts, maybe it's just before apogee, they might hit apogee and then start coming down in the belly flop. Oh, maybe you mean the flip maneuver like at the end? That flip maneuver? That might be what you mean. Sorry, I just had it was my epiphany. According to Flight Club is estimating that flip maneuver to happen at, let's pull it up here real quick. They're estimating the flip maneuver to happen at less than half a kilometer. What is that, like 0.35? 350 meters? That seems very late. But Declan at Flight Club is way smarter than I am when it comes to this telemetry stuff, so. Oh. We got reports of a police siren, which could mean we're 10 minutes away. I wasn't expecting to hear a police siren. That's usually the notification that they have that we're 10 minutes away. But we weren't expecting that today because usually they sound the police siren because the people in the Boca Chica village, like they're supposed to come out of their house, but right now Boca Chica village is completely evacuated, so not sure why they would have a police siren, but that would be interesting. Waiting for SpaceX. SpaceX was supposed to start right about now, so I'm guessing maybe... See, I'm thinking... Let me update the time real quick. I think we're like 10 minutes away. Where I can't move fast enough. Now I'm getting the jitters. Now I'm getting the jitters. I think we're like 10 minutes away here. That's my guess. Let me see. Oh, a couple people. Flight Club is estimating we're 5 minutes away. I don't know. I don't know at this point. I'm ready to bounce off the walls. I'm just getting amped up. Okay. WB-57 positioning for launch. So that's our tracking plane here, high altitude observation plane. Looks like they did a little flyover towards the site, and now they're heading back. They're a little ways away here. But yeah, we should be getting pretty close here. Now we're waiting on SpaceX to see if they go. We're expecting that we're about 10 minutes away, 5, 10, 15 minutes away, somewhere in that range. Like, we can't be too far off now. Oh, SpaceX is live. Oh, here we go. Sound the alarm. Holy smokes. Okay, get it over here. Wait a minute. Oh, too many keys. We're 4.5 minutes. Why is this in such terrible quality? HD. Auxiliary. Come on. This one. Oh, goodness. Oh, here we are. Oh, wait, I got too many things playing. I gotta mute NASA space flight because they're in my ear. We're gonna pause them so we don't have any streaming issues. Pause up here. I hear no audio. So I'll keep the music up for just a bit. So we're... Oh, boy. Oh, look at this. We're, Let's see. Let me get my Flight Club stuff so it's updated. I want to make sure... I want to try to get the times to match up. I'm like 2 seconds off. Let's see. Set the time. Yeah, there we go. My countdown clocks are now synced when it comes to Flight Club. So here it is. Holy smoke. I don't hear anything. Oh, wait. Maybe I got it muted. Oh, I do have it muted. There. I can hear it. Oh, baby. Oh, goodness. Oh, my goodness. Oh, my goodness. Did I say, oh, my goodness? Oh. Wow, I'm just checking my clocks. Oh, we're 3 minutes away. Oh, this is happening. Holy smokes. Holy smokes, guys. This is the real deal. Oh, my goodness. All right. We got this. Sound the alarm. I don't know what that was. Share the stream. Tell your friends. Share it. Subscribe. And thanks to all our supporters and Patreon members. Oh, I just don't know what to say at this point because I'm all amped up. Okay. Deep breaths. Yeah, right? Oh, all right. Yeah, that thing is massive. We're getting ready to go. Oh, is it going to happen? This is going to be the first time that Starship has launched to like any major altitude. We did some 500-meter test flights. This is going to be...
2 minutes.
Oh, we got mission control audio too. 2 minutes. We got it. This is like the first real flight. Nose cone, everything. Like, holy smokes. Don't forget the telemetry. I got the telemetry. Some people said, why are you 8 seconds behind? Don't forget the feed's got to come to me first and then to you. So, of course, it's going to be a little bit behind. I got the telemetry. Oh, wait. My telemetry's off again already. How are we off? How did we get off?
Global. Okay, global.
There we go. I got it back on again. It was just off by 2 seconds. Okay. Yep. Oh, man.
Copy.
Guys, you got to share it. This is your last chance. Tell everybody this is history right here. This is the future of space flight. We're a minute away. Oh my goodness.
Oh. 1 minute.
It's still going. It's still going. Okay. Okay. We're still, yeah. Oh, jeez. Remember, this telemetry is simulated. It's an educated guess. It's not guaranteed. Simulated telemetry, but it should give you a rough idea on what we're expecting. It could be completely wrong. I don't know. I don't know. I just don't know. And again, if it fails, if it does not land, it is not a failure. This is a test flight. 1 in 3 chance it even lands. Oh my goodness, we're 15 seconds away. Oh, oh no! We got a hold. Oh no, we don't have a hold. It was just a quick.
5, 4, 3, 2, 1. Raptor abort.
Oh, Raptor abort. Ah, we had an abort. Ah. Oh, man. Gosh. Oh, we had an abort. Let me put the text up. Oh, jeez. Oh. Man. .3 seconds. We were 1.3 seconds away. We had a Raptor abort. So, obviously something... So, at 1.3 seconds, the Raptors would have been going through their ignition process. So that starts at like 2.8 seconds. So they would have been going through ignition. And they stopped, obviously. Some sort of anomaly. Now the question would be, I don't think they have enough time to recycle. There's only like 23 minutes left in the window. And there was something weird. There was something weird that happened like right around 10 seconds. There was like a brief hold, which was really weird. I didn't know what was happening. I was like, oh, abort. Oh, nope, just kidding. Didn't abort. So we don't know if they're gonna try again. I kind of doubt it, but there's a few minutes left in the window. There's 23 minutes left in the window. So that could be enough time. It could be enough time. I don't know, let me see. I'm laughing at... One of my buddies sent me a text message about my danger cone comment. Oh, gosh. Why aren't they telling us anything? All right, don't forget, this is a test flight. This is an internal company test flight. They are under no obligation to tell us anything. There's no commentators for this. They were just like, all right, they weren't even planning to live stream it, I don't think. But I think the community pressured them into doing it. Like, they would have been like, guys, we don't even know if this is going to work. We're not going to live stream it. But I think at the last minute, they were like, all right, fine, we'll live stream it. So they're under no obligation to tell us anything about what's happening here, because this is an internal company test. So we did get the engine spin up. Standing down for the day. Yep, there you go. Because we're at the end of the window. There's just not enough. There's not enough time left in the window to go for it today. So we'll put that up there. Oh, man. We were so close. We were 1.3 seconds away. Raptor abort. So the engine spun up, but we didn't get the full ignition. So, you know, there's sensors in there. If they didn't get the full... If something happened and they didn't get a correct pressure reading or a correct fuel flow reading or oxidizer flow reading or something like that, they would abort. I mean, those things happen fast. So the engines are supposed to ignite at like 2.8 seconds. It aborted at 1.3 seconds. So in that 1.5 seconds there, they went, something ain't right. So then we've got an abort for today. Man, how do they get the fuel out? So there's still, I mean, just like they get the fuel in, there are lines that connect to it. They'll be able to recover a lot of the methane, especially. They'll be able to recover because, and even the liquid oxygen, they'll be able to recover a lot of that. The methane, they have a methane recondenser, so even gaseous methane, you know, they can recondense it back to liquid, and they don't have to burn it off in the flare stack. We used to see a flare stack here. Because you can't just release methane into the environment. You gotta either burn it off or recondense it. So follow at SpaceX for the next test opportunity. Oh man, gosh, we were so close. And again, remember, a couple things. One, internal company tests. Like, this is not a failure. Like, this did exactly what it's supposed to do. If it ignited and it blew up, like, and they didn't discover it, like, all right, maybe you want to argue failure at that point. Like, all right, that's fine. But this is exactly what it's supposed to do. Like, they're supposed to have systems on it to abort if something goes wrong. If you're under any sort of impression that rockets will always work correctly 100% of the time, like, you're living in a fantasy world. I even say that about Falcon 9, which has been flying for years and years and years. If you're under the impression that Falcon 9 should launch perfectly every single time and never have things go wrong, that's fantasy. It's not, you're not living in real life. Things are going to go wrong. But where you have your successes is you have systems and sensors in place to detect when things go wrong, expecting that they will go wrong, and that's how you pull this into a success. I mean, if this thing just blew up and they didn't even fly it, like, that's a bad day. But this is going to live to fly another day, hopefully tomorrow. You know, we have two more windows open, tomorrow and Thursday. That's under the current TFRs that have been filed. So we could go through this whole thing again tomorrow. I don't know if my heart can handle that, but that's probably what the plan is. Adam Pearson, wow, so much excitement, then an abort. I know, tell me about it, right? Oh God, I thought it was going. I'm like, my eyes are darting around. So I got to go back and watch the stream because I'm looking at everything. I'm like, my stuff here, my stuff there, my stuff here. It's like, is everything okay? Let's see. When will it fly? Well, so my best guess would be they're going to try tomorrow. I mean, it depends on what went wrong. They didn't really... Oh, there we go. So we lost the... We'll just back it up so people can see it. So we don't know exactly what went wrong. We know that the engines triggered an automatic abort. So this would have been an automatic abort, not a manually triggered abort from mission control or anything like that. This would have been an automatic abort. And are there words? Are these words on this camera right here? Or is that just flare? Or is that like clouds? Like, that looks like text. What is that? Skywriting, maybe? Does anybody know what that is? I don't know what that is. anyways, so, oh, replay text. Yep, thank you for the reminder there. Whoever just said that, Spinny Witch, thank you very much for reminding me to put the replay text up. Okay. So, yeah, like I said, it didn't blow up. That means we're going in the right direction. Yep, that's the thing. You're seeing the Matrix. Oh, man, there's so much excitement and then nothing. But that's all right. That's all right. It's a test flight. Last thing we want to see, we don't want to see a kaboom boom. We want to see the thing fly. No kaboom today. No flight today either, but more importantly, no boom boom. Okay. It looks like a watermark, yet somehow backwards. I know, that's kind of what I was thinking too. I was like, it looks like a watermark or like some kind of text or something. I don't know. What was all the debris to the right just before launch? Well, let's take a look. Let's go look at. Because I think I blacked out. I think when we came down to launch, I think I blacked out for a second. So I gotta watch it again just for me, because I don't even know what happened. This is like, let's turn the replay text on. Where is our replay text? Let's throw that. Oh, put it right here. Okay, this is our replay of what happened. Let me see if I can watch this again without just blacking out from excitement. I don't even. So this is supposed to land itself like the Falcon booster. Yes, yep, that's the idea. I'll show you in a minute. Maybe we'll go back to Kerbal in a little while and I'll show you what is the idea, but you should look at your reaction during launch. I'm sure I will, but I'm sure one of our Discord members is going to create a GIF out of it.
QD is retracting.
If you want to join our Discord, I'll put a link in the YouTube chats, and all my Discord members will be freaking out. So I'll put a... if you want to join Discord, it's free. There's no cost to it. Oh, is my bot not working? It puts the Discord link in? Oh, there he is. Nightbot. So you can join Discord for free and chat it up with us in between launches.
4, 3.
Hold on. Pause this. I want to go back. Let me finish saying what I was going to say. If you want to join Discord, it's free, and you can chat it up in between launches. This is pretty much where we were chatting all day today, trying to find out whether it was going to launch. We're on Discord, chatting it up. So if you want to get that sort of like latest update information, you join the Discord, and I'll put a link in the in all the comments so that you can join if you want to join, and then you can be part of the circle here, part of the team, and you'll find out about stuff like this. So. And then I guess I'll say also while we're here, because I usually put these two together, if you want to join the inner circle and you really want to help support the channel and you like this kind of thing, you can consider becoming a Patreon member or a YouTube channel member. You get some behind the scenes access, some access to exclusive live streams and stuff that we do in our secret Discord channels for just Patreon and YouTube members. So if you want to take that extra step, consider that as well, but if you don't want to shell out funds, I understand. No big deal. You can join Discord for free and just chat with us. Okay. Let's replay this here now, because I want to make sure I catch it. So right there, like right at 13 seconds, there was something weird that happened. 24, 23, 22, 21, 20. I'm going to count it all down for you. Because right at 13 seconds, something weird happened. 15, 14, 13, 12. No, pause. For a while. 11, 10, 9, 8, 7, 6. Yeah, all right, let's see what happened.
4, 3, 2, 1. Raptor abort.
Oh yeah, so you can see it all happening here. Like you can see
3,
right in the engine
2,
camera right here.
1. Raptor abort.
Yeah, you can see you get fuel flow coming out of the combustion chamber there, or liquid.
1. Raptor abort. 1. Raptor abort. 3, 2, 1. Raptor abort.
me turn it up a little bit louder here for you.
Two.
So yeah, really weird. How long was that? How long was that hold that they had there for just a couple of seconds? That was kind of weird. That was interesting.
QD is retracting.
Let me see. I want to see how long that hold was for. It was like a 4-second hold.
5, 4, 3, 2, 1. Raptor abort.
Yep. So then we had the abort. You see all the fuel flow happening here. All the venting happening in the top view. That little side camera. See venting happening here now. Yeah. All right. Oh, all right. Well, yeah, it's about looked like about a 4-second hold. And so, yeah, we'll go back to this view here. So the people that are joining now, they know that there's not going to be a launch. It's scrubbed. It's not happening today. So, who was that? Somebody said it failed to ignite the fuel from what I see. Yeah, we don't know if it failed to ignite or if it chose not to ignite. So if there was some sort of fuel flow issue or some pressurization issue, the engine ignition itself could have been either aborted or terminated to prevent some sort of an issue. So we don't really know. We don't know if it failed to ignite or if it was or if it chose not to ignite. Let's see. Let's see what else we got here for comments. Funny how your speed and altitude was going up, but the thing never moved. Yeah, so the altitude there is, remember, that's just simulated altitude. That was this from Flight Club. Like, I have to manually sync it. Like, I tell Flight Club when to start the metrics there, and that's, I can only click so fast. So once it aborted at 1.3 seconds, I had to stop it at some point. There was a weird noise before abort. Yeah, I think that's all, that's just the normal spin-up noises. We don't hear that very often, but that was, that's the sound of basically the engines and the turbo pumps and all the valves and turbo pumps opening, getting ready for...
QD is retracting.
Getting ready for ignition there. QD, that's the quick disconnect. Pretty sure that's what they're talking about there. There's our 4-second hold, which was really weird at 13 seconds.
Five, 4, 3, 2, 1. Raptor abort.
Yeah, and so that little bang sound that you hear right before it, I don't consider that unusual. That was that's basically just your startup, your spin up, and ignition procedure there. Why was it aborted? We have no idea. All we know is it was a Raptor abort. So that would presume to mean there was some sort of issue with the actual ignition process. Could be fuel flow, sensor reading. It could be a bad sensor. Could be actual problem with fuel flow. Could be a problem with pressurization, the pressurization was outside of the acceptable range. It could be that the ignition itself just completely failed. So there's a bunch of things that could be there. We don't know. We just know there was some sort of Raptor abort, which basically means the sensors that are controlling the actual Raptor engines just noticed a problem and said, not happening. Nope. 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 Not doing it today. So that was that's all we know, really. When will they try again? It should be tomorrow. Same sort of window. So it'll be tomorrow from 9 a.m. to 5 p.m. Eastern time? Eastern time. 9 a.m. to 6 p.m. Eastern time, which would be 8 a.m. to 5 p.m. Central time, which is like 1400 to 2300 UTC. Maybe concrete got launched up into the Raptors. Oh, we didn't have any. There was no ignition, so no, I don't really think that. Is it AM or PM? Well, it's all day tomorrow, so 8 a.m. to 5 p.m. Central time. Pretty much all day tomorrow. 1400 to 2300. Very embarrassing. I disagree with you. I'm sorry. I hate to tell you, this is a test. This is development. Like, I don't know. It surprises me. Like, anybody that thinks that this is going to go perfectly, I just want to know what fantasy land you're in. Because, like, honestly, I would have been shocked if it went and it didn't abort. Like, this is actually not shocking to me. Like, yeah, I was excited that it was going to launch, but this is not shocking. I was actually kind of surprised that we were even trying today. I thought it was going to abort today, and we weren't even going to try, which is why I didn't live stream all day. I didn't think it was even going to launch today. So the fact that it aborted at 1.3 seconds, for that matter, is actually kind of shocking to me that we got that far. So yeah, if there's a lot of people they're like, oh, it's an abort. It's an embarrassment. I disagree. This is a development test flight. Like, it's pretty expected that things might go wrong. Delayed launch. So we're actually, I'll put this back up. We're actually scrubbed for the day. So they aborted at 1.3 seconds. It's not happening today. They'll try again tomorrow, 8 a.m. to 5 p.m. Central Standard Time, 1400 to 2300 UTC. And again, if you're going to come back and join, which I would love you to do, that would be fantastic if you did it. I have no idea, and nobody's going to know when it will launch until about an hour to an hour and a half before the actual launch. Then we might know. Then we'll have a kind of a rough idea. This is why I tell you to join the Discord and become an active member in our community here, because we've been chatting all day in Discord, talking about what's going to happen, what sort of developments we're seeing. Is the high altitude plane taking off yet? You know, is the pad clear? Are there still personnel that are working on it? So all that stuff was still happening today, and we were chatting about it over on Discord. So if you join the Inner Circle, which is free, there's no cost to it, you can kind of chat it up with us and get some of those Inner Circle updates. And that's pretty much how it's going to go tomorrow too. Is we're going to have to just wait and see what happens during the day. Like, I don't expect it will go like right at the opening of the window, but I'm going to set up a live stream that is at the opening of the window, just in case it does. And then throughout the day, we'll look for clues and see. It's like playing Rocket Detective here. You just look for clues and tidbits on like, oh, it's getting closer. Is it going to happen? We don't know. Like, you play Rocket Detective all day. And about an hour to an hour and a half before, that's when I send out a notification on Discord that says, sound the alarm, we're going. So that's the idea. Expect more delays tomorrow. It's not really a delay. Everybody says delay. It's not really a delay. They're not publishing a time at all. They're just telling you we might go tomorrow. And it could be as early as 8 a.m. Central, but no guarantees. So it's not really a delay. It's just more like we're still guessing what's happening. I bet someone at Mission Control fell asleep. Yeah, not so much. This was an automatic abort. So this was not triggered by Mission Control. This would have been automatic onboard computer systems that triggered this abort. Remember, that abort happened in 1.5 seconds. So this is an automatic abort. Let's see. No reason for the abort. All we know is it was something with the Raptor engines that caused the abort. So we don't know whether it was an ignition problem, a fuel flow problem, pressurization problem, bad sensor. We have no idea. Something with the Raptor engine system caused the abort. That's all we know at this point. Jason Ellingson, setting my alarm to cricket noises. Thanks, Jason, one of our members. Appreciate the support there. It already aborted. Yep, we aborted about, what was that, 25 minutes ago now. So now we're just going to kind of take questions and see if we can answer some things. You should know the reason so you can fix it, right? Nope, it's above my pay grade. Do you know what Among Us is? Yes, we play that with our Patreon members sometime. I actually just played Among Us yesterday or the day before with some of our Patreon members over on our Discord. So yes, I do. And if you become a Patreon member or a YouTube channel member, you can join me and play Among Us sometimes when we do that. So let's see. Will you be in Discord afterwards? Yeah, I'm sure I will be. Let's go up to a couple. Is there a way to watch the SpaceX live stream also? Well, this is the SpaceX live stream, and they're done. So I'm just replaying it at this point, just so there's something on the screen. It's like watching paint dry. I mean, this is this is a business purpose here. Is rocket launch, is corporate rocket launches here. Like it's not a.
2, 1.
We'll put it all the way back to the beginning. We'll replay the whole thing. Why not? Let's see. Oh, there we go. That means that the computer is smart enough to stop a problem seconds before launch. Yes, yep, that's exactly what that means. Those computers are super powerful, and they're monitoring all kinds of systems prior to launch. And eventually, like, once you get down to, like, 30 seconds, maybe even more than that, before launch, like, at that point, most of the time, humans are going to be hands-off, and they're going to be automated systems. If humans are going to call an abort, usually that comes 30 seconds before launch or sooner. After 30 seconds prior, you know, then, for the most part, they're leaving it up to the computer systems. Like, the humans are going, like, everything I see here looks okay. So let's go, and then the computers make the decision after that. It launched, it was just so fast and landed again, we didn't even notice. Yeah, it's the Starship traveling at light speed. The launch and landing at light speed. Let's see. Abort is not a setback. An exploded rocket would be a setback. This is very true. Very true. Why was the mission aborted? We don't know for sure. We just know that it was something with the Raptor engines. Again, fuel flow, pressurization, ignition, bad sensor, something along there, something in the Raptor engine system itself. Had an anomaly detected that was not ideal for flight. And that's exactly what it's supposed to do. If it launched and then detected an anomaly, that would be a problem. That's something you want to fix and not do that sort of thing. So Gree says 13 seconds was from your end. It lagged a little bit, and then it came back. The mainstream didn't freeze. Well, this is the mainstream. Like, I don't control this time clock here. So that was on SpaceX's end. That the 13-second hold there, because it held at exactly 13.0 seconds, and then picked up. Like the stream didn't freeze. That was an actual hold by SpaceX. It was kind of weird, but. Yeah, that's directly in the SpaceX stream. Like, that's SpaceX's clock. That's not my clock. I'm just showing it to you. Abort is normal. Yep. It's all right to have an abort.
2 minutes.
No problem here. What about fuel? Can they remove it? Yeah, a lot of the liquid oxygen gets lost, they can recover some of it. The methane, they have a methane recondenser. They can recover and recondense the methane back to liquid form. So they can recover pretty much all of the methane, I believe. Liquid oxygen is another story. That's they're going to lose some of that.
Go global. Pack global.
Is this the real one or a small replica? This is full size. This is a real size. That's the actual size that it will be. Don't forget, though, it will have a first stage booster on the bottom. So this is just the upper stage. This is stage 2. We haven't even seen stage 1 yet. This is 50 meters tall. Stage 1 is 100 meters tall. SpaceX Fan 2 over on Twitch. So wants to know when the next launch window is. It'll be tomorrow, 8 a.m. to 5 p.m. Central Time, 1400 to 2300 UTC. Is that the view from the hopper? I don't think so. I guess I don't know where this camera view is from. I would have to get my bearings. I don't know. I don't know which direction we're looking. I don't see the hopper anywhere.
QD is retracting.
Is tomorrow's launch confirmed? Nothing's confirmed. The only, like I said, we play space detective here. It's pretty much what the entire space community does. All of us content creators and news agencies, like, we're just playing space detective. So we're looking at things like the NOTAMs that are out there. That's the notice to airmen that tell you not to fly planes here.
4,
Show you this replay here real quick
2,
so you can see what happened.
1. Raptor abort.
Let me back it up so you can
3.
hear it. Oop. Uh-oh. Oh. They killed the stream. Oh. Okay. Let's bring it back over here. Here we go. I'll turn it up so you can hear what happened.
5, 4, 3, 2, 1. Raptor abort.
So that's what happened earlier. About 30 minutes ago, we had the attempt, and then we had a Raptor abort. Essentially meaning that they gave it a shot, and they went to the ignition process. Something happened during ignition. Fuel flow, pressure, sensor reading, bad ignition. Something happened. It didn't ignite. They aborted the flight. They're scrubbed for today. They'll try again tomorrow. 8 a.m. to 5 p.m. Central Time, and we'll be back here again. Is this a test firing? This would have been a test flight, not just a test firing. It would have been a test flight. So the idea, let's walk you back through in case you weren't here for the beginning of the stream here. Let's pause that. We'll turn up we'll get you a little elevator music or something, a little chill music. So this is what they're doing here today. So it's a test flight up to 12.5 kilometers. So this is looking south. We can spin around. We can look to the north. This is in Boca Chica, Texas. The idea is it's going to go under powered flight. Hopefully this is now tomorrow. Get rid of the replay text for you for a minute. But it'll go under powered flight up to about here. Coast up to apogee, right up here. Flip on its side, do this belly flop maneuver, down like this. You gotta excuse my model because I'm missing the centerpiece. It's actually 3D printing right now. It just wasn't done for the live stream here. So now it'll be done for tomorrow. So you're gonna ride up all the way to apogee, belly flop down, use these what we're calling the flapper doodles or the ailerons. Remember, I had to explain this earlier because somebody thought I just couldn't pronounce ailerons properly. I'm saying ailerons. Like Elon Musk. Like, it's a joke. It's funny, huh? It's funny. Okay. Anyways, or we just call them the flapperdoodles. Okay? You get the flapperdoodle thingers, they're going to do their flapperdoodle stuff. Okay? To do the flapping. Sometimes they flap in, sometimes they flap out. Okay? So the flapperdoodle, you're probably going to flapperdoodle in. Like this. And it's going to fall on a belly flop. Might even pitch down to kind of steer, because at this point it's like an airplane. So it's going to come back towards the launch site, belly flopping. Then right at the end, right before landing, let me get you on the 3D map here. Let me, zoop, like this. Oh, whoa, too far. Back her up. Oh, that's too far that way. Uh-oh. Oh, now I did it. I'm lost. Oh, there it is. Okay. So then right here at the end, it's going to target away from the launch site. So if it doesn't landing, if the landing burn doesn't work, it's going to land over here off to the side of the pad. But so it's going to come in, and then it's going to do this crazy flip maneuver right at the... Ooh, almost broke it. It's okay. It's all right. We're good. Okay. Calm down, everybody. Mostly talking to myself. Okay. Let me put it back together. Get back in there. Okay. So it's going to do this, this crazy maneuver right at the end. I haven't glued this thing together yet because I need the middle piece still. Where it's going to, as it comes in, it's going to flip around with the engines burning, burn this way to null its horizontal velocity, and then touchdown. It's crazy. Big belly flop, flip over landing maneuver. So that's what we're expecting. Big flight. This is groundbreaking. This is history in the making. One, nobody's ever tried to land like this before. Like, that's insane. I mean, nobody really has tried to land a rocket before in general, before SpaceX started doing it. But yeah, now we got the flapperdoodle things. Like, nobody has flapperdoodles on their second stage. This is second stage that we're landing, not just the first stage. So, and nobody's done that flip around maneuver. Like, a lot of crazy things. It's a methane engine, 3 Raptors, one of the most powerful engines ever built. There's 3 of them on there. It's going to be some craziness when it happens. Hopefully now tomorrow we'll have that craziness. But that's roughly what we're expecting, and this animation is courtesy of my friend Declan over at flightclub.io. And this is not official data. This is an educated guess. Declan's a super smart guy, and he's able to work this stuff out because he's a magician. And so, yeah, this is a very educated guess as to what's going to happen, but it's pretty darn close. Let's see. I still flapperdoodling. Yeah, Ron, I'm still flapperdoodling. My friend Ron Sparkman over on Facebook. We did it earlier, and we got to do it for the latecomers, so we could teach them about the flapperdoodles. Tomorrow, yeah. So the next launch attempt is tomorrow, and it's still a big maybe, because we don't know what went wrong. Like, was it just a bad sensor that they have to replace? Was there some sort of little minor issue that they can just touch up tonight? Or, like, are they going to have to take the entire Raptor engine out and put a new one in, or fix it or repair it or something like that? We don't know. We'll find out over the coming hours, and that's why I tell you should join our Discord, because you can chat with us for free and get in our community circle here, and you can find out about stuff like that behind the scenes. That flipping will be hard to do. Yeah, it's kind of crazy. There's a bunch of 3D animators that have shown this, that have come up with 3D animations and simulations of how that's going to work. They're crazy. They're insane. Like, I mean, I think they got it right, but like, just my mind doesn't accept that that's going to happen in real life. You know what I mean? That's what I'm like. I've seen it. I know the engineers have thought this through. I know they've simulated it. But I'm still like, all right, prove it. Like, I mean, I'm sure it'll happen, but it just there's that little bit of disconnect for me in my mind where I'm like, you know, I've seen the animations and I'm like, really, that's gonna happen, huh? All right, cool. Like, I mean, I'm sure there's super smart people that have come up with that. I just can't picture that in real life. It just seems like it's just all animate. Oh yeah, okay. I'm not gonna go too far because as Ron mentions, he says flat earthers and flapperdoodles. That's the official title of my show now. A couple people have commented about like the ride, like if you're an astronaut, like what that flip over maneuver is going to be as a ride for a ride. Well, Declan, he's, like I said, he's a magician. He's answered some of this kind of stuff. So acceleration wise, like we're only talking, according to Flight Club's estimates, we're only talking like right here, let me zoom in on this. 2.8 G's of acceleration at that, like right at that flip over maneuver. 2.8 G's. Nothing too crazy. Like that's doable. But even with that being said, we don't know if that is, you know, what the seating is going to be like in the Starship. So they, like, you could develop some sort of seat that's almost like a gimbal, like a camera gimbal, right? So, you know, your seat, if you know that you're going to have to do this crazy whip around thing and you don't want to give people whiplash or make them sick to their stomach or something like that, so like you could develop a seat that gimbaled and would always face up, for example. So as you're coming down like this, like your seat, which would normally be, you know, if you're like this, you're going to face up. And then it comes like this, like you're still facing up. The seat, the whole seat could gimbal. So as the rocket does this, your seat, you know, let's see, how do we do this? Your seat's like this, right? And then a rocket does this, and your seat just stays there. And it falls, and then the rocket does this, and your seat just stays in one spot. Now, that's completely theoretical. We know nothing about that. They've not said that they're doing that, but just talking theories of like things that you could do. Black Panda, they're not going to do the Raptor flip. They're going to have small boosters on the side that flip it straight up. No, I'm pretty sure the Raptors are what are going to do the flip. Is the Raptor engines. So I'm not expecting our cold gas thrusters to do that flip maneuver. It's going to be mostly engine flipping, which came directly from Elon Musk. So he said directly on Twitter that the actual engines are doing the majority of the work there on that the Flipperama. Why was it scrubbed? All we know is we had some sort of engine issue right at 1.3 seconds. OLHCN sounds like a radio amateur call sign. Am I right? No, Jeff. I do have an amateur radio call sign, but that's not it. OLHCN is just an abbreviation for Overlook Horizon. Your seat does not stop gravity. That's not what I was saying about the seat. The seat, really, the gimbaling thing I was talking about is mostly just to make it comfortable for you so you don't get sick to your stomach from being flipped around. You know, if your seat stays in one place, like, yes, you're still going to feel gravity, but you're just not going to be flipped around like a roller coaster. I mean, will you still get sick to your stomach even if the seat holds still? Yeah, maybe. I don't know. I mean, astronauts have already reported that they get sick to their stomach just in a capsule landing and bobbing around in the ocean and things like that. So that's not necessarily unusual if they do get sick to their stomach. I mean, it's space flight is not for the I don't know, weak stomach, I don't know. Space flight is hard. Let's just say that. Do we know when the SN8 launch will happen? Well, they tried it about 45 minutes ago. They scrubbed it. They got down to 1.3 seconds, and then they said, nope. So they're going to try again, hopefully tomorrow. Tomorrow is the next possible opportunity, but we don't know for sure whether it's actually going to happen. How about your brain? Can it handle the G-force? 2.8 Gs is not a lot for your brain to handle. Fighter pilots, and they can regularly pull 7, 8, 9 Gs. Like, mean, 9 G's is getting kind of high up there, but yeah, they can pull a lot of G's. Even the Crew Dragon pulls up to 4 G's. So we're talking 2.8 G's here. That's not a ton. Like you're gonna have G-force training as an astronaut, so you'll be able to handle 2.8 G's. That's the least of my worries on that flip around, is the G-force. This seems shorter than most 2-minute Tuesdays. I like that, JR Knight. That's funny. That's funny right there. Record for humans is 11.6 G's. There you go. That's according to A-Bomb 1710. He says the record is 11.6. More than I want, but... I heard they'll pull the same G's as an F1 driver when they do the flip. Well, I don't know how many G's an F1 driver pulls, so I have no idea. But I mean, Declan has done the math here, done the simulation. He's got about 2.88 G's right at that flip around maneuver. I don't know how to go back to reset. There we go. This is the G load right here, acceleration. So you can see it right at launch. You're talking 2.17. Then you get your MECO, your engine cutoff, and then you're gonna pretty much go to 0 G when you hit apogee. Then you start coming back down. You're gonna get some force felt from the resistance there, air resistance. Then you'll have your flip around ignition. Boom, quick spike to 2.8 G's. So that's it's Declan from flightclub.io. That's his simulation. So, and that's like, it's not just he didn't just draw it on a piece of paper and was like, yeah, looks good. Like he mathed this. He mathed it out. Are they still set for launch today? Nope, we're scrubbed for today. Next attempt will be tomorrow. F1 drivers can experience up to 4.9 G's lateral force at full speed. I mean, I wouldn't be surprised if that flip around causes 4 or 5 G's, but right now, according to Declan, he's predicting about 2.8. I mean, but this is an educated guess. I wouldn't be surprised. I mean, even 4 to 5 G's, I wouldn't be surprised if that's what they actually pull during landing, but we'll have to wait and find out. Bruce McNinch, one of our members. Thanks, Bruce. Appreciate your support for the channel. Says hitting your brakes too hard can cause 3+ G's. That's a good point. I guess I don't know what the actual G load is if you do slam on your brakes, but... and Anita, another one of our channel members. Thanks, Anita, for your support. Anita and I chat all the time over on Discord. Destin from Smarter Every Day met a female pilot who can stand 9.3 G's. She is amazing. That is amazing because I'm pretty sure I could not withstand 9.3 G's. Pretty sure Tori's going night-night at 9.3 G's. Be nighty-night for Tori if we pull 9.3 G's. Good night. Another early morning awake. Yeah, we'll be back at it tomorrow. And again, if you're coming back tomorrow to watch, like, it's gonna be... I have no idea what time we will actually see this go. Like, will it be... I doubt it's going to be right at the opening of the window at 8 a.m. Central. I was hoping today that it would be more like 10 or 11 a.m. Central, but you know, obviously they pushed it back all the way to the end of the window today. So we have no idea. We'll chat about it on Discord. That's how you can kind of get the inside scoop if you want to, you know, get up-to-date information throughout the day. And then if you turn on notifications and subscribe to the channel here, then you'll get notified as soon as I go live. But I gave people on Discord a little bit of a heads up, like, hey, things are happening. So we kind of knew as we got closer, like, oh, all right, we're about maybe 2 or 3 hours away. Oh, we're about an hour and a half away. Oh, looks like it's going to be an hour. We're going to go live in 10 minutes. And then we went live. So yeah, there you go. Nomadic says TFR dictates they cannot launch prior to 9 a.m. Central. Yeah, you wouldn't be able to. I mean, the hazards start right at. Is that actually in the text of the TSR or the TFR? Because here, I got the TFR up here. Oh, no, that's not it. So this is the TFR. This is tomorrow's TFR. So TFR, for those that don't know, is a temporary flight restriction. It basically says, like, no, right here, no pilots may operate an aircraft in this area covered by this NOTAM, except as described. And basically, you'd have to get some sort of special waiver to fly within here, which is what, like, the NASA WB-57 does, because obviously they're allowed to fly there, but runs from 1400 to 2300. I mean, I don't think there's any specific text in the TFR. We can look at the NOTAM text itself. This gets a little bit cryptic. So this basically says, like, from ZHU, which is Houston, the Houston ARTCC in Texas. It's an airspace NOTAM for Brownsville, Texas. Temporary flight restriction with an area defined as, and then this is a bunch of coordinates to define what the area is, from surface to unlimited, which means that the NOTAM runs from ground level to all the way where they stop controlling the airspace, which is usually around like 60,000 feet in altitude, to provide a safe environment for rocket launch and recovery pursuant to 14 CFR section 91.143. Aircraft operations are prohibited in this airspace unless authorized by air traffic control. Houston ARTCC, which is ZHU. That's what it's saying there. And you're gonna test my memory on this. ARTCC stands for, who's a pilot that remembers what that stands for? Air Traffic Control Center? I don't know what I mean, I know what an ARTCC is, but I just always call it by the acronyms. I don't know what it actually stands for. Somebody remind me what that stands for. I'm blanking on that. So, yeah, I guess as far as the NOTAM's concerned, there's not actually a specified time that they can launch, but the NOTAM doesn't go active until 1400. Like, they're not going to launch at 1400. They got to make sure the airspace is clear first. And, like, you're allowed to be in the airspace until 13:59:59. So they're generally not going to launch until at least an hour. So oh, there you go. Big pods, the Air Route Traffic Control Center. That's right. I remember now. Thank you. And Nomadic said that. Thank you very much for reminding me of that. Will there be any live streams tomorrow? Yeah, we'll do the same thing tomorrow that we did today, which is basically, like, I'm gonna put up a live stream event. There'll be another event on the channel shortly after I finish here. And put this up just so people can see it in case you missed it. But we'll have another live event, and throughout the day, I'll update it with what I think the time will be when we go live. I mean, unfortunately, YouTube doesn't have an option that says, like, I don't know. I gotta pick sometime. So I kind of just, like I said earlier, we play Rocket Detective, try to see, are we getting close? Like, what's happening? So we're gonna try to figure that stuff out and come up with a time to go launch. The idea is to go live about an hour before the launch time would be. So really, probably the biggest thing that I will be looking for tomorrow in order to go live will be takeoff of the NASA WB-57 aircraft, because once they start flying that in the area, then we know, like, all right, we got an attempt. So it's actually kind of a combination of things. I'm looking for the WB-57 aircraft to take off. I'm looking for the pad to be clear, so the SpaceX personnel, like, off the launch pad. because they have to do that before they even start any fueling. When they start fueling, that takes an hour. So I'm looking for the pad to be clear, looking for the WB-57 to be in the air, and I'm looking for some sort of tank farm activity indicating they're starting fueling. So when those three things happen, then I will be going live. And that's basically what was happening behind the scenes today. If you were checking out the channel and trying to figure out what was happening, that's the decisions that we were making. There you go. Nomadic says N927NA is the assigned WB-57 chase aircraft for the test this week, for what it's worth. Thanks for that. Yeah, I was tracking that today on Flight Aware. Something elsewhere in the rocket had a problem, and something in it must have triggered the abort. Well, so what we know is that it was a Raptor abort, so something in the Raptor system itself, which could be fuel flow problem, pressurization problem, ignition problem, or just a bad sensor problem. Could be any of those kind of things, or it could be something else that I don't even know about, but those are kind of the common ones. But that's all we really know about what the abort was. And it was an automatic abort, not something triggered by mission control. Nomadic says there's two versions of the TFR. Oh, all right. The public version and the internal FAA version. I have an internal FAA version, which dictates they cannot launch until 1 hour past the in effect. Okay. I'll trust you. I'll go with Nomadic on that. Yeah, obviously I've not seen the internal one, but I'm not even necessarily doubting that that's the case. Even if there wasn't an internal one, there's no way they would launch right at the opening of the TFR, anyways. But that's interesting. I have not seen a internal FAA NOTAM, but I trust you.
Go global. Pad global.
Let's see. Start it.
Copy.
I don't know what that question is. I'll turn this back up so you can listen into the replay here while I'm going through some questions. All right, I'm going to play.
T-minus 1 minute.
I'm going to back this up for a bit. I'm going to let you see the full replay. I'm going to see if we have any updates real quick while you're checking this out. Loudest bird ever. Boy, is he in for a shock when it actually does launch.
T-minus 2 minutes. Go global. Pad global. Copy. T-minus 1 minute. QD is retracting. Five, 4, 3, 2, 1. Raptor abort.
All right, so we'll turn it down just a little bit and grab a couple questions that I saw pop through as I was looking for updates. No real major updates that I've seen so far. But yeah, obviously we didn't have a launch. This was from an hour ago. So this attempt was from an hour ago. It scrubbed at 1.3 seconds before the planned ignition time. A couple of people said like, oh, why did the engine start before T0? That's pretty common. I mean, really, T0 can be just about any time that the rocket company decides that they want it to be. So you have some companies that, like the old space shuttle days, they would ignite the main engines at 6.6 seconds prior to liftoff. Liftoff was 0. 0 is when they would ignite the solid rocket boosters. That's kind of what SpaceX uses. Generally, 0 is the actual liftoff event. But in order to have 0 be the liftoff event, you have to ignite the engines and check the engines before 0. So the engines usually ignite at about 2.8 seconds is when that's supposed to fire up. Now also, keep in mind, it's pretty common for the cameras to be behind the countdown clock. Usually there's a little bit of a delay there with cameras, depending on which camera you're looking at. So if you look at the left camera, you can actually see the fuel flow starting before we see it in this camera that's right above my head here. So so this one's a little more delayed than the feed that's over there that I can't actually point to. So you can see right at about 2.8 seconds, you see fuel flow in the far one. Starts flowing out. So you get full propellant and liquid oxidizer flowing through there, and that's the point where you would have an ignition, but that just didn't come, or it was terminated before it could really get underway. So yeah, that was a problem for today. And then you can see all that, the clouds and everything else, and the stuff that you see like shooting out of the side here. This is all liquid oxygen. It's venting off and condensing. So you'll see like a shoot, little, yeah, right here, the little liquid oxygen. I don't know what to call this, but it's just venting out the side. That's completely normal. We would have seen that vent, even that big burst vent there happens with the Starship right just at ignition, so that's not unusual. But obviously, we didn't have an actual launch itself. All right, hold on. I have to. I need to deal with somebody that's trolling. So there's always one bad apple in the bunch. I don't know why. It's all right. You just send your trolling comments, and then you get banned, and it's the end of your day, at least with me. Yeah, we don't know whether it was a sensor or an actual failure. All we know is Raptor auto abort. can you explain the color change on the body? So the color change you're seeing there is likely due to that super cold, the super cold fluids there, and you're getting a little bit of it's kind of like what you would see on Rocket Lab, that you get a little bit of like ice or frost buildup on the side of the rocket because it's super, super cold. Like liquid oxygen is generally like negative 340 degrees Fahrenheit or something like that. When is the new date? So it could be as early as tomorrow, but it really depends on the don't know what just happened there. Did my stream just end? That was really weird. So it could be as early as tomorrow, but we don't know for sure. It depends on what the reason was for the abort. Like if the engine is just bad or it needs to be repaired, they're gonna have to take the engine out or, you know, do what needs to be done. Like that could be a long process. It could be days. It could be they might fix it in 2 seconds. But we just ran out of launch window, and so they couldn't do it today because they had to push it to the end of the launch window, and so we just ran out of time for today, which is honestly not surprising. Like it was surprising to me that we made it to 1.3 seconds. Somebody want to know who was trolling? It was on it was not on YouTube. It's one of my other platforms. I'm not going to mention it because we don't want to encourage that kind of behavior. What about the first stage of Starship? They're getting there. They're working towards that, but they're starting with the second stage, and then they will get there. I like how Nomadic said that it was over the lunch net. Sounds delicious. Finding a weather window. Well, so let's look at somebody talking about weather window for launch. So weather in Boca Chica is generally better than it is in Texas, or a little more stable, or in Florida. Better and more stable than Florida, not Texas. Boca Chica is in Texas. My mind is fried. We didn't even live stream for that long today, but my mind is fried just because all day I've been staring at this stuff, trying to figure out what's going to happen. So the question really, I mean, we don't know what time it's going to launch. We just go like midday. Like winds, this is tomorrow. Winds are looking okay. Got no problem for winds. Like what do we look at? Cloud cover, not really looking that bad. That's today's satellite. Let's see, precipitation expectations. Do we have any precipitation tomorrow in Florida? No expectations for precipitation. Or is it still loading? I see, because I see, oh yeah, there we go. So, I mean, I don't think we really have a problem. Let's look at like upper level winds. Upper level winds are getting a little bit speedy, but that should still be okay. But that is getting a little quick. But see, look, this is what I'm talking about. The difference here: 100 miles per hour over in Boca Chica for upper level winds. Over at Cape Canaveral, 150 mile per hour. That would be scrub territory over at Cape Canaveral. Over here, 100 miles per hour. That could be okay. They might be all right with that over at Boca Chica. 150 though, that's the scrub zone right there. Getting over at Cape Canaveral. So if you got to launch tomorrow in Cape Canaveral, you could be in scrub territory with those upper level winds. But other than upper level winds, which are high but not super concerning, like I think we could be okay. A couple people asked, like, what is it supposed to do? So we'll look at this again. Here's our 3D map from Flight Club. This is the idea. So this is looking north up the beach here. It's going to launch underpowered flight from the launch pad, which is here. Get rid of the replay text. Launch up here. End powered flight here. It's going to coast, glide, slow down, reach apogee, and then it's going to turn sideways. I'm missing the center section to my Starship here. I know it's not the exact Starship. The center section is 3D printing right now, but it's not done yet. It's going to belly flop down. It's going to use the flapper doodle thingers. or Elonerons, right? You explain the joke every time. Elonerons. Somebody didn't get the joke earlier and just thought I was an idiot. Anyways, and I didn't come up with that name. I don't know who did, but maybe Everyday Astronaut. Somebody came up with it. But gonna belly flop down, use the flappers, right? Gonna use our flappers to kind of make sure it stays upright, stays in the right orientation, maybe pitch down, maybe pitch up, depending on like how it's trying to get back to the launch site. It's pretty much gonna come just about straight down, but it's not completely straight down. If you look at Flight Club's estimation here, you can see that it takes a little bit of a pitch out to sea, but then it's got to come back. It does this just a little bit, just a little tiny bit, comes back. And then as it comes down on that belly flop maneuver, right at the very end, then it goes back under powered flight for the landing. And to do that, it has to go from the belly flop to standing up. So they're going to use the main engines for that. Burn the main engines, but of course they have to start in this position, which is going to introduce horizontal velocity. So they fire the main engines, introduces horizontal velocity, they tip it over, gimbal the engines, they have to overcorrect, over gimbal it to burn this way to null out that horizontal velocity they introduced when they started up the engine. So they overcorrect, burn this way for just half a second, and then come back down. So it's they're gonna be falling. Swing like a pendulum. Whoop, yep, whoop, boom. Picture perfect landing. And if it does that, I will be shocked. I don't expect it to actually do that, but I mean, that's what they're trying for. I don't know why I don't expect it. It just seems like mind-blowing to me, like crazy. Like I don't know. So that's the idea. Is this a Mars ship? Eventually, yes. I mean, not this particular one. Like, this particular one is just a prototype, right? So this is just a prototype vehicle. They're testing it. They're learning how to... Nobody's ever done this before. They're learning how to build a stainless steel rocket with flapperdoodles, right? I mean, you got to go through the flapperdoodle testing procedure. You figure out if the flapperdoodles will do the flapperdoodle thing, right? So they're testing it. And you got to go... It's hard to go from 0 to 100 in 1 second. When I say 0 to 100, I mean like development-wise, not like actual speed. Because this all is experimental, and they're not like they're testing this by real-world testing. A lot of other companies, like, they'll do simulations upon simulations until they're blue in the face, which I'm sure SpaceX does simulations, but SpaceX also likes to put it in the real world and say, like, all right, we did all these simulations, like it says it's going to work. Let's try it. Let's see if it actually works in real life. And so that's their methodology. So this is completely a test. It's not a guaranteed success. They have no obligation to tell us about anything because this is internal corporate testing. It's a private company. They're doing their own private company thing. They have no obligation to tell us anything. This is not part of a NASA mission or something where we need like government oversight or, public information. Like, I mean, you'll see some public documents for like the FAA, what they have to review, and the FCC and things like that. But this is a private company developing their own product that they just happen to share with us. Let's see. We've been waiting months for SpaceX to do this. Well, yes, but SpaceX is also one of the most transparent and open companies when it comes to seeing this development. I mean, when's the last time you saw the United Launch Alliance's Vulcan tests? We don't see those at all. How often do we see Blue Origin run development static fires and test flights and things like that? They don't show it to us. They don't show it until they actually have a real mission. Like, nope, nobody else does this kind of stuff. When is it going to happen? So next opportunity is going to be tomorrow, 8 a.m. to 5 p.m. Central Time. The secret writing around the rocket is some sort of elvish. Well, I saw Scott Manley posted, so we're talking about like this secret, what looks like text here. Scott Manley posted a Twitter about this and said it kind of looks like some sort of burned in watermark to identify any leaks. So that could be possible. Like, that could be some sort of subtle burned in watermark so that SpaceX can internally identify like how leaked video might have got out. Also discourages employees from leaking video in the first place, because building rockets, like, you gotta be very careful if you're an employee with leaking information, because you have all these ITAR restrictions that you have to follow, and of course they have internal company, privacy and proprietary things that they want to protect. But it does kind of look like it could be some sort of burned-in watermark to identify like leaked videos. I would buy that. I'd believe that. And yeah, because those ITAR restrictions, just because it's a commercial rocket, like rocket technology is also missile technology, and we kind of protect that stuff. We don't want to share missile technology outside of the country.
T-minus 1 minute.
I'm gonna read a couple questions. I'll let you watch the replay another time here.
QD is retracting.
Hold on, while you're watching this, I'll be right back.
Five, 4, 3, 2, 1. Raptor abort.
Okay, I'm back. I had to step out for a second. Let's see. So a couple people, so let's go back through, we'll analyze this abort here again. As Nomadic points out, this is an automatic abort. This would not have been called by mission control or launch control. This is an automatic abort that happens with the onboard computer system.
2, 1. Raptor abort.
So you can hear them call out Raptor abort. They're basically indicating that the something in the Raptor system found an anomaly and had an automatic cutoff. So that's completely automatic. There was, interestingly, at 13 seconds, there was a weird hold that caught me off guard. Like, that kind of freaked me out. But this is a completely different vehicle, and there may be tolerance for, at least in this stage, like in development-wise, that they could hold the count briefly if they wanted to have like an extra second to look at something. That's possible. So I don't know, right here at 13 seconds, you'll see it hold, and it holds for 4 seconds, right there. Holds for 4 seconds. And then it starts up again. And then, so I don't know what that was about. And then the ignition process starts. So turbo pumps are spinning, fuel and oxidizer are coming through the engine valves. You can see it best on the left screen there, because this one here is kind of delayed a little bit. I mean, you can see it here too, but this is a little bit delayed. So you'll see right at, here's our 13-second hold, which was really weird. I still don't know what was up with that. Yeah, they say Raptor abort.
4, 3.
On the left screen, you'll see
1. Raptor abort.
So you can hear the engines kick up, it's turbo pumps and valves spinning up. You see all the fuel flow out the engine nozzle, which is normal. That's what's expected. Fuel and oxidizer start flowing. But then what's not normal is you would expect an ignition to happen, and that didn't happen. So that was an automatic abort. And again, that was, well, at this point, it was over an hour ago. So all right, I'm going to show you one last thing here. We'll go through, we'll pull the music back up. And we'll go to this view. Nope, not that view. Let's see, I want this view, but I need this window over here. I need it up there, like that. There we go. Let's change this text here. So people know. And it's scrubbed. We'll move it over there. Look at this. This is called producing on the fly. Okay. Get that playing just so we have something going on. All right, so what I was going to show, we'll show the simulation here again. This is through Kerbal Space Program one more time, just to get an idea, so people can get an idea of like roughly what it's supposed to look like. This is going to be a terrible representation, but I'll show you anyways, and we'll try it. So we would get our ignition here. So 3 Raptor engines. Eventually there will be 3 sea level, or 3 vacuum Raptor engines on the outside. 1, 2, and then another one over here. 3. But we don't have those yet. Right now it's just the 3 sea level Raptors that are mounted in the center. Eventually we'll get some vacuum optimized Raptor engines as well. We haven't gotten that yet. I'm expecting to see the rocket. Actually, I guess I'm expecting to see a roll program like this, maybe. I don't know which orientation it's facing, but expecting to see it. Oh, nope, not that way. Pitch over towards the water. A touch. Oh, this is going to be a 15-kilometer hop because I wasn't paying attention. And then we get... Oh, it's getting unstable. It's already unstable. Here we go. Whoa, whoa, easy. 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 Okay. There we go. So we could even get like... You could even get like a whole flip around maneuver like this. Like that would be kind of radical looking. I don't know exactly what that belly flop... The beginning of that belly flop is going to look like. So, that's... Then it will start coming down. And we don't exactly know what this is going to look like either. Like, is it going to be... We'll get our... Like, we don't know which ailerons, the flapper doodles, which one they're going to use. Is it going to pitch down? Or is it just going to be completely flat? I mean, it's going to have to... I think it's going to have to pitch down at least a little bit, I would think. Or is it going to pitch up to... You know, because somehow it's got to push back to the launch site. I think I'm even a little bit too far. We're going to have a water landing again here. Because ideally, like, it's got to somehow push towards the landing site. And I'm doing a terrible job of that right now. I don't know how to do that, so... Oh, yep, okay. Here we go. So we got it. Yep, no. We don't know what the flap orientation is going to be. I'm kind of expecting it to be something like this. I think I got too much horizontal velocity. Like I'm just traveling way too far downrange. It's all right. We'll land in the water. Here's our belly flop. Coming down, what are we at? 2,500 meters. Look at, see there, now we're falling pretty much straight on. So obviously they would stay around the launch site and not do such a poor job like I did, but I'm gonna cheat and use MechJeb and tell MechJeb to land it. See, this is one of the interesting things, like flying this with Kerbal Space Program, is like once you get to a point, like the lift that the whole body has. And obviously Kerbal Space Program is not like completely real physics, but the lift that the whole body has is kind of crazy. Like we're coming down so slowly. Here we go. Then it'll kind of do something like this. You can see it pitch back to null the horizontal velocity. It's not a ton, at least not in this Kerbal simulation, and then you get the nice little landing there. Boom. And obviously we're in the water, which is not ideal. But there, that's the idea. All right, let's get rid of that. And I guess we'll go back to this view here, because I'm gonna wrap up here. We've pretty much gone through as much as we can go through, I think, at this point. We're gonna wrap up, but I would tell you, consider jumping on our Discord, because we'll chat more today, tomorrow, as things are leading up again. Maybe we'll have a launch tomorrow, so consider joining the Discord. It's free. If you want to take the extra step, maybe support the channel. If you like this kind of stuff and you like what I do, Overlook Horizon here is a 501c3 nonprofit charity organization. So any funds, whether you're a Patreon member or a YouTube channel member or a super chat or anything like that, none of it comes to me. It goes to the nonprofit, and that's really to help further our mission here, which is to spread spaceflight education, to get kids, students, adults interested in this kind of stuff, interested in science and technology. And so all that money is towards those objectives, whether it's helping make these videos look a little bit better, more informational. That's what it goes towards. So anyways, there's my sales pitch. If you want to support the channel, consider becoming a Patreon member or a YouTube channel member. It helps. And even if you don't want to do any of that kind of stuff, just being here watching is pretty awesome. Love having you guys here. Love everybody that's chatting. You're contributing to the show. All your questions. That's all fantastic stuff. It helps me make a better show when you guys are engaged and interested in this kind of stuff. So appreciate that. But you can join the Discord for free. There's no cost to that. So if you want to jump in and just become part of the community, you can join Discord, and there's no cost to that. Can SN8 be seen from Brownsville at its highest altitude? I don't know for sure, but I don't know how far Brownsville is away from the launch site. What's the distance there? Let's see. Measured distance to, where is to Brownsville? That's like 35 kilometers. Maybe might be hard to see. I don't know. That might be a little bit far to see it. That would be my guess. I think it's a little bit far. Let me go. I can grab a couple questions before we wrap up. Look at the stream. There's weird letters above the clouds. Yeah, so we talked about those letters a little bit. I think Scott Manley put out this theory, which makes a lot of sense. I think there's some sort of like burned-in watermark to prevent leaked videos. I don't know that for sure, but we think that might be the case. What if it goes in the water in real life? Well, that would not be ideal, but they'll clean it up. Vinvaz says, I think KSP makes the flaps have a lot more lift than it will in real life. Yeah, it could be. In KSP, the flaps give it a ton of lift. Like, it's really weird. I can almost fly it like that, but... Everybody run, Tori's doing Kerbal. Isn't that the truth? Yeah, Nomadic makes a good point. SN9 is ready to go if SN8 goes for a swim. Yeah, so it wouldn't be a huge... It's not going to be a huge setback to any sort of development if SN8 lands in the water or crashes to the ground. It won't be a huge setback because SN9 is right behind it, ready to fly, and we don't even know if they would use SN8 again anyways, even if it did land successfully. So they're building a whole bunch of versions, like one after another. So even if SN8 just swan dives into the ocean, it's not going to be a big setback. The question would be, what did you learn during the swan dive? Because even remember, it doesn't have to land to be successful. This is a test flight. They're trying to learn how to do this. So if they learn something out of it, that's the success. Landing is not the criteria for success. Learning something about this vehicle that you didn't know before the test, that's the objective of the test. All right. Oh, there you go. Nomadic says SN8 is done after this. There you go. That doesn't surprise... I mean, I wasn't really expecting SN8 to fly again, but Nomadic's got the definitive word. I hate saying things definitively if I don't know for sure, because I'll say it definitively and then somebody will point it out that I'm wrong. All right. Well, I think at this point, I think we've covered it in depth. So it's time for me to wrap up. Remember, consider joining the Discord because, like I said, there's no cost to that. You can join part of our community, and hopefully we'll chat it up with you tomorrow as we're getting ready for hopefully another launch attempt. Maybe tomorrow. We don't know for sure. We have no idea. That's the next possible attempt. They have a TFR for tomorrow, temporary flight restriction, so it could potentially fly tomorrow. But we just don't know. We don't know. We have to wait and see. I'll create an event, and you can turn on your notifications when we go live, and or you can join Discord and get up-to-the-minute details, and if I know it, you'll know it in Discord while we wait to see what happens. So, all right, everybody. Well, that's going to do it for me. My name's Tori. This is Overlook Horizon. I'll see you guys tomorrow. Hopefully we'll get another flight attempt tomorrow. I'll see you tomorrow. Goodbye.